this week or next. And I'm not changing my mind about that, but I do have some homework for you guys to do over the break. The good news is, really what I want you to do is go and play some video games over the break. And I want you to do that. Wait for it. I'm not that nice. What I would like you to do is have a look at Pygame. It's an environment, or rather a support library for making video games in Python. In particular, these are sort of 2D video games, so not 3D graphics or anything. And what I'd like you to try and do is download and install it on your machine. Do your best to do that. And the game comes with a bunch of samples that you can play. So really, I do want you to play some video games. So download it, install it, make sure you get the version that's for the version of Python you have, 3.7 or so. If you just Google Pygame download, the first thing that comes up is the download page for it, and on that same page there's a bunch of videos on how to install it. I can't offer much support, but TAs can during things like tutorials and office hours, because there's at least 3 OSs people are using in this course, and I don't know the details of installing Pygame on every OS. And on the OS I'm using, it's trivial. It's a one-line command. So what I want you guys is to do that sometime in the next 2 weeks. Play some of the games to test it out and make sure that it's working on your system. Because when you come back, I don't want you having to fight with the installation of this thing. And if you struggle at all, post a message on the course forum. There'll be lots of other people probably facing the same problem. Okay. Any questions about that? All right. Okay, so then time for the main event, I guess, what you all came here for. And that is the sample midterm. I think this year we will have something like 21 questions plus a bonus question. It is a multiple choice Scantron exam. What you have to do is show up here, preferably 5 minutes early. The exam will take place from 2:35 until 5 minutes to 4. So you have an hour and 20 minutes. And bring a pencil and an eraser with you, because it's multiple choice Scantron. Pencils work best on Scantron sheets, and it's nice to be able to change your answers rather than have to fill out a whole new Scantron sheet. Okay. And the questions are like the ones we'll see here, little bits of Python code, sometimes larger bits of Python code, and you answer a multiple choice question about it. So who wants to answer question 1 for me? Yeah. Pardon me? B, 8. And that's because 2 plus 2 times 3 is not evaluated from left to right. Rather, there's this order of operations, and multiplication has higher precedence than addition. So just like you probably learned in some school somewhere, this multiplication happens first, giving us 6 plus 2 gives us 8. Okay? So the answer is B. So ignore already before the questions even begin, there's a bunch of stuff about using the parameters qnew and from future import division. That's old stuff from Python 2.7 that was actually there to make Python 2.7 behave like Python 3, so that things like division make sense and we get reasonable results. Okay, so what is the code 2 divided by 2 equals 2 div, 2 divided by 3 equals 2 div 3, evaluate 2. False. And why is that? 2 divided by 3 equals 2 div 3. So in this question, we also have to think about order of operations. Low down on the list of priorities are comparison operators. They come after all the arithmetic operators, and so in particular, this equality test here is way down on the list. It won't get done until the end. We first want to do the two arithmetic operations. So what does 2 divided by 3 evaluate to? What's that? 1. Nope. So 2/3 gives what kind of number? A floating point. So it's going to give something like 0.666 and so on. 2/3, what is // supposed to mean? It's division without any remainder. So it's sort of the kind you learned when you basically first started to learn division. And so what is 2 divided by 3 if I'm not interested in the remainder at all? 0. Because 2 goes into 3, or 3 goes into 2 0 times. There's only remainder left. Okay. Or if you like, in the floating point version, it's this part that comes before the decimal point. Okay? And then finally, this operator gets evaluated, this equality test, and is 0.66666 equal to 0? Not under any reasonable definition of equality, and so that is false. Okay? So while I go through these questions, and after I go through these questions and on your own and on the forums, what I would like you to do, so the midterm that we're going to have is going to be very similar in format to this. So what I would like you to do is use your imagination and think, oh, what kind of other questions could he ask that are like this question that I'm looking at right now? And that's really your best way to study. And maybe it'll expose, maybe you'll be able to ask some questions that you won't know the answer to. Feel free to put them on the forums. And it may expose your own weaknesses. And so you should really do this, especially if this was one of the ones that you didn't see the answer to right away. You should think, okay, what are other questions like that I need to understand? And if you don't understand something that we do today, please stop and ask me. But if you still don't understand after that, then get some help. Talk to another classmate, ask a question on the forum, see a TA, whatever you need to do. Okay, so question 3. If A and B are two variables of type float, then what is A times B? What type of thing is it? Yep, it's also a float. So if I take two floating point numbers and I multiply them together, I get a floating point number. And you can try, one thing you can do in this, in studying or even looking at this exam is, it's really easy when you have the practice exam and a Python interpreter, because half of these questions are, what does Python do with this? Well, you could copy and paste that into Python and see exactly what it does. If you want to check your answers. And the same things with the questions you come up with. You can put them into Python, see what it does, and make sure you understand why that was the answer. If A and B are of type float, then the expression A less than B is of type. So this I kind of glossed over, so I'll say it now. The types that we have seen are floats. These are these numbers that we see that have a decimal point in them. Ints, they're integers. That's more or less the first thing we saw. Strings, characters, sequences of characters. We know what those are. And these values, true or false, that pop up, like, for example, when we compare two things, those are of type bool in Python. It's short for Boolean. And does anybody know where that word comes from? No? Anybody know where the origin of the word Boolean? Yeah. Yeah, it's an Irish mathematician, I think, named Boole, George Boole, who I think his work was kind of ignored in its time as being, I don't know, maybe uninteresting or without applications or trivial. But it turns out that Boolean algebra is an incredibly important part of computer science, and by extension, discrete mathematics. So there you go. A little piece of trivia. The word Boolean is named after a person, Boole. Another thing to look out for, and I don't know if hopefully I've dispelled this already, but I had a friend once who did an entire PhD, actually. He reached doing a PhD in computer science, and he'd always seen this word Boolean everywhere. And something happens when you read a word a lot before you ever hear it pronounced, is you come up with your own pronunciation. And so this fellow, on the verge of getting his PhD in computer science, is giving a talk talking about Boolean things all the time, mispronouncing the word Boolean because he didn't realize it's named after someone. He just thought it was Boolean was the pronunciation of it. It's not. And the last type of thing is, the last sort of thing here is object. We've looked at objects and dealt with them, but you won't have a question where I ask you if the type of something is an object. So A less than B is the value true or false. That's a Boolean value. So the expression A less than B gives you a result of type bool. Okay. Question 5 has a piece of code that maybe looks familiar to some of you. Hopefully looks familiar to some of you. So question says, and it's old Python syntax. Let me translate into modern Python. So that's what the code would look like in the modern Python. Light so you can see better. Or not at all. That's a bit strange. Okay. All right, so question says, what does this function return? If I call it with the 3 arguments, the string pat, the string moren, and the string dr dot. What does it return? D. Moren, comma, pat, doctor. The string moren, pat, dr. Okay, so there's lots of possible options there. Some of them are there to really see if there's a gross misunderstanding. So hopefully you recognize that if I give you a string and call format on it, that the result is a string and not a triple of things, or something of the completely wrong type. And then it's just a matter, that narrows it down to really two answers, C and D, and then it's just a matter of looking at the code and figuring out which one of those two it is. And that's following through the arguments that are in the call to the function, mapping them onto the names that are defined for those arguments in the function itself, and then looking at the print statement or the return statement to see where those things are used. Okay, question 6. There's a function here with a name that is sort of indicative of what it is. Into feet in, I takes one argument called I and returns I div 12, comma I mod 12. So if I call it with 74, what will it return? So first of all, what kind of thing will it return? A pair, right? The return statement here is returning two things separated by a comma. That gives us a pair of things, so it's going to return a pair. And actually, once you've deduced that, you already know the answer, because there's only one pair that's a possible answer to that. Otherwise, you can do the division. You have to take 74 and integer divide it by 12. That's going to be 6. And you have to take 74 modulo 12. And if you did the integer division longhand, you will know what that value is. There's a remainder of 2, so you'll figure it out there. So you can shout or not. Who thinks they could answer a question like this? Okay. So if you didn't put up your hand, then please follow my advice and go through this thing. Come up with your own questions like this. Talk to friends. They can come up with their own questions like this. Test them out in Python to see that the answer that you think it is indeed the answer that it is, and prepare yourself that way. Okay, so here are two functions. One is called, they're both called stars, so two definitions of something called stars. One of the functions takes, so they each take an argument n, and, looking at them, I would guess maybe that what they're supposed to be doing is returning a string consisting of n stars. And the question is, do these two things return the same value? So that first one, the first longer one, again, ignore the x range. Just think of it as a range. It's something that's sort of gone now from Python 3. So what's that first one doing? So the first one starts with S being an empty string, and then it counts with this variable I from 0 to n minus 1. It doesn't use this variable I, but it repeatedly adds another star onto the end of S. And again, this is maybe something we didn't do in this course because I don't want to confuse everybody with more and more weird operators. But S plus equals something, in this case it's a star, that's the same thing as S equals S plus star. It turns out that in programming, this kind of expression is so common, where you are accumulating things like, in this case, stars at the end of a string, but often it's things that you're adding up, a running sum of things, that there's a shorthand for it, which is this plus equals operator. And that always reads like, whatever the variable is on the left, add this thing to it. And assign it to the variable on the left. And actually, there's all of those things. There's minus equals, times equals, even slash equals for division. Don't read too much there. So indeed, I believe that this function does do what its name suggests. It returns a string which is consisting of n star characters. And this one multiplies n by the string star. What does that do? Yeah. Yeah. And what's the result of that? What? Yes, it's an error, and this is a little subtlety in Python that kind of, actually, I don't like. In particular, I don't think they should have even introduced this string multiplication operation. If I take an integer and I multiply it by a string, I get an error. If I take a string and I multiply it by an integer, I get a string. So this actually is an error, but if I had done star, the string star times a, so if this code looked like this, times n, then that would indeed return a string of n star characters. But this gives an error. So they don't return the same value. In fact, one of them doesn't return at all. It just throws an exception. Yeah. What did it give you? Okay, so that may be a difference then between Python 3 and 2 again. So in 2, this maybe gives an error. At some point, this gave an error. So whatever the correct answer is here, in the current version of Python would be whatever we were using for the course would be the right answer. Here is another type of syntax that we haven't seen at all in this course, so I wouldn't worry about it. Rather than list comprehensions, there's an operation, or in addition to list comprehensions, there's an operator in Python called reduce that they now recommend you don't use anymore in Python 3. So we'll ignore that question. Another reduction operation. Okay, so here's a piece of code that does a list comprehension. It's a function called bar of a. I guess a is going to be a list, and it returns x cubed for x in a. So if I call it with the list 1, 2, 3, 4, what's the output? D. because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So it gives you D, the list 1, 8, 27, and 64. If you recognize this as a list comprehension, and hopefully many of you do, then you'll recognize that it will be returning a list. At that point, there's only two options, two reasonable options. If I give it a list of length 4, and it's this simple list comprehension, then it should return a list of length 4, so that's B or D, and then you only need to check a couple of values. Okay, here is a more complicated piece of code that might take some time to work through. There's a function called niceHour. It takes an argument called h, and if h is 12, it returns noon. Otherwise, it has this list of names, midnight 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and it returns names at h modulo 12. So if I call niceHour 17, what's the return value? So if h is 17, is h equal to 12? 17 is not equal to 12, so it won't return noon. So instead, it's going to compute h modulo 12. What's 17 modulo 12? 5. If I take 17 and divide by 12, I get 1 with a remainder of 5. That's what the modulo operation does. And now you have to go into this array, this list called names, and look and see what's at index 5. 0, 1, 2, 3, 4, 5. The string 5. Okay. And that's answer B. So if you see a question like this, don't panic. Don't throw your hands up in a panic and cover your eyes or run out of the room screaming. Just take your time and go through it slowly. You have a piece of paper, you can write on it, you can do things like, you see that you're calling niceHour with the argument 17, so you can write up here, h is 17. Scratch out the h if you like, replace it with 17. And from there, you just work through it slowly and carefully to get the answer. Or, if you're unwilling to do that, take a wild stab at it and hope that the function does what it's supposed to do and guess 5. You can try that. Does anybody have a question? A lot of whispering back there, like people are confused. Yep. If the brackets were not there, and what was there instead? Yeah, if it was just h mod 12, then it would be the number 5. And what if I call it with the argument 29? So is 29 equal to 12? No, so it's not going to return noon. The next question is, what's 29 mod 12? Well, we can fit 12 into 29. We can even fit 24 into 29. And that's as much as we can fit into 29. So 29 divided by 12 is 2, with a remainder of 5 again. And so 29 mod 12 is 5, just like 17 mod 12. And at that point, we don't even have to count anymore. We know it's going to do the same thing that it did for 17. Okay. Any questions about that? Okay, so here is well, that's not too bad. There's a little bit of syntax issues here with the way Python formats strings, or the way we used to format strings in this course. This thing here you can read as translate that into string.format, where you have a string with 2 sets of curly braces, and the first one is replaced with first name, and the second one with last name. But now you have to do a little bit of reading some code. It's a necessary skill as a programmer, not only that you can write code, but also that you can read it. So you have to take time to read this thing. So this is creating a class called person. In Python 3, we don't need to say that this class is an object. That happens by default in Python 3. And a person has an init underscore underscore init underscore underscore function, which takes 3 arguments. Like all objects, it takes the first argument is self, and then a first name and a last name. And like all of the objects we've seen, this initializer just saves the first name and saves the last name as self.firstname and self.lastname. It has a function called underscore underscore equal, EQ underscore underscore. What's special about this function, EQ? Did an example of this, well, last class, I guess. What? Yep. Yeah. So this underscore underscore EQ function, when you define it for an object, it redefines what it means for this object to be equal to something else. In particular, it defines what it means for self, the current object, the thing on the left-hand side of the equals equals operator, to be equal to other, the thing on the right-hand side of the equals equals operator. And this one is not a super safe one, but it's fine. It says that this person is equal to the other person if this person's first name is equal to the other person's first name, and this person's last name is equal to the other person's last name. And then there's a underscore underscore str underscore underscore function. Remember, this is the function whose job it is to convert this thing to a string whenever it's needed. In particular, if you call format, string format with one of these things, it converts it to a string and prints that string representation. And this just says, well, if you could read Python 2, you would see this just prints the first name and the last name. Okay? Or it doesn't print. It returns the string that is the first name, then a space, then the last name. So here I create a person and assign it to the variable PM1. And we can make a picture of what that looks like. We have our stack. And we have a variable there, a little box called PM1. And we've created a person whose first name is Pat, and whose last name is Morin, lives over here on the heap. And this box, PM1, refers to that person. Next thing we do is we do the same thing again, but this time introducing a variable called PM2. So that's another little box over here on the stack. That becomes a person. Again, we're calling person, so this is creating a new person, and looks just like the other one. And then we assign it to PM2. Okay, and then I'm printing, well, before printing, I'm doing this equality test. PM1 equals PM2. So what's the result of that? True. And working through that, that's because PM1 is a person. The person class has the equal method defined. So when we want to compare PM1 and PM2, this is how we do it. And we see that, well, this returns, well, it checks if the first names are the same, and if the last names are the same, and both of those things, so it's the and of those two things. So if both of those are true, then it returns true. So PM1 equals PM2, that is true. Next it asks, PM1 is PM2. False. And the way we know that is by looking at this picture over here and seeing PM1 refers to this thing over here on the heap, and PM2 refers to a different thing over on the heap. They happen to be treated as equal, but they're not the same thing. Is that clear? So I'm deliberately doing these fairly slowly and making pictures and everything else. So I want you, during the exam, anytime something is not crystal clear, what the answer is. And even if you think it's crystal clear, but there's some nagging doubt, make a picture right there on the sheet of paper that you're working with. Do what you need to do to sort this out. So make a picture like this one. Do whatever you need. So then the question says, here's the code. What gets printed? Well, it will print true for the first one, and then false for the second one. So it will print true, then false. Almost the same question. What's the difference in the code here? What's the difference between the code in question 14 and the code in question 13? Yeah. 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 So the difference is right here in this line of code. So when the first line of code executes, this is indeed what the picture looks like. We've created PM1, it refers to this person. When the second line of code executes, the picture looks like this. We introduce the box for PM2, but it refers over here to the same person. It gets a copy of whatever is stored in PM1, and what's stored in PM1 is a reference to this person, so this is also a reference to the same person. So with that picture, there, we see that they'll still be equal because they still have the same first name and they still have the same last name. But now they're also identical. When I say PM1 is PM2, what I'm doing, what Python is doing, is looking at the contents of these two boxes, and indeed, the contents of these two boxes are exactly the same. They're both refer to exactly the same object. Is that clear? Yep.
If the first and last name changed, would it be exponential?
So you're saying, for instance, if I added a line of code somewhere in here that changed someone's first name? Okay, so let's say that I change PM1's first name. So let's say I take PM1's first name and I set it to Patrick. So PM1's first name is over here, and I change that to Patrick. Now I ask if PM1 and PM2 are equal. Are they equal? Yeah, because by setting PM1's first name to Patrick, I'm also setting PM2's first name to Patrick because they refer to the same thing. Back on the previous page, here if I had changed the first name for PM1 or for PM2, but not for both of them, then indeed, then they wouldn't be equal. They would stop being equal. But in the second example, there's only one object in the picture here over on the heap, so whatever we do to it, it's going to affect, well, it's just going to affect that object, and there happens to be two things that refer to it. Yeah?
So does your original entry still exist on the heap, or is it gone from memory when you set PM2 to PM1?
Good question. Does it still exist on the heap? Let's say, for the purposes of this course, that it does. And so I say for the purposes of this course because Python is what's called a garbage collected language. And garbage collected languages, every once in a while, they go and look around at things, everything that's on the heap, and they ask, is there anybody that's referring to this thing? And if not, then they say, well, we can clean this up so that they just don't keep using more and more memory. So if this was all the code in my whole program, or if I say PM1 is a person, PM2 is a person, and then later I set PM2 equal to PM1, and that's the only thing that ever referred to that thing on the heap, then it might go away. But you'd have no way of knowing that because you don't have any other way to get to that thing anyway. So you can imagine that it's still there, or you can imagine that it goes away. But if there was a third thing that referred to that, if there was a PM3 that referred to this, then even if I change PM2 to refer over here, well, as long as PM3 is still holding on to it, it'll stay there. And next time you look at PM3, it'll still be there. Okay. So the best thing is think of these assignments, this equals, the one equal thing with the one thing on the left-hand side. So the assignment operator, all it does is change the content of the box here. It does not affect things over here on the heap. Okay, and here we get to something that's already outside of what we've done in this class. So in object-oriented programming, there's this whole notion called inheritance, where you can create classes which are specializations of other classes. Here's an example of it. We may or may not do it later in the course. It's not critical, but this is a new class, and it's a special kind of person, meaning that it also does all of the things that a person can do, but it's a musician, so it has, in addition to a first name and last name, it has an instrument. I don't expect you to be able to follow this, and I really don't expect you to understand what this ugly little bit of code is doing. Again, this is something that changed in Python 3 to be still almost as ugly. But yeah, the point here is that a musician is, in this example, is really a special kind of person that just has an extra little thing associated with it, which is the instrument that they play. And the way you convert a musician to a string is you make a string which is their first name, their last name, and whatever instrument it is they play. So Pat Moran, trombone player, for example. So yeah, here we again, there's rules then once you do this. Well, now string is defined for musicians and it's defined for persons. Which one gets called? If you had studied this stuff, you would know all of this. But we're not going to. I think we're not going to bother with it too much in this course. It might come in a little bit later when it comes in handy for making a game or something. But it's not a critical lesson. Okay. Question 17. There's a function here called negated. It takes an argument A, and it has a comment that says returns a list having only the values x in A, where minus x is also in A. So it says I'll return a list comprehension, and in that list comprehension, I'll return the value x for every value x in A if minus x is also in A. And as far as I can see, that does what it promises to do. You give me a list that contains every value x in A for which minus x is also in A. So the code is not incorrect. That's not the answer. The code is correct. And then there's a question that says, is it fast or is it slow? In particular, if A is a really long list, is it fast or slow? So have we ever written code like this before? Yeah. Slow. And why is it slow? Yeah. Yeah. So the whole raison d'etre for sets is that it's very fast to test if a particular value is in the set or not. So that's the sort of defining property of sets is membership testing, meaning testing if something is in there or not, is very fast. This thing, on the other hand, is a list. I mean, it's supposed to take a list as an argument, or in particular, if the argument is a long list, then it goes through for each element in the list, and then it searches the whole list looking for the element minus x. So for each x, it searches the whole list looking for minus x. And that's not a particularly, searching for something in a list is not a particularly fast operation. If there's 1 million elements in the list, and you have to, and the thing you're searching for is not in there, the only way that that gets determined is by looking at each element and seeing that it's not the one you're looking for. So this will be correct but slow. In particular, it takes a long time if the list is long. And we saw this, it doesn't have to be so long, right? We did this with looking for anonyms in in the dictionary, that's only about 100,000 words in that dictionary. And we had one code that when we used a set, it just ran instantaneously. And when we didn't use a set, it was taking like a minute or two to do this. And that's only with 100,000 items. A dictionary is not a particularly large amount of data. Okay. Here's another function called unique. Takes an argument A and says that it returns the list that you get by converting, when you make a list, out of the set that you get by converting A to a set. So let's look at the options for this code. Is it fast? So sets are fast. Adding things to them is quick. So converting it to a set is a fast operation, and converting a set back into a list is a fast operation. So that's true. The code is fast, even when A is a long list. Next one. The code returns a list containing each distinct element of A exactly once. So if I give it a list that looks like this, then what happens when I convert that list to a set? Yep. Yep. So then set A will give me something like 1, 5, 2, 6. And then when I convert that back to a list, that'll give me 1, 5, 2, 6. So returns a list containing each distinct element of A exactly once. So that's also true. Next option. The elements in the return list appear in the order of their first occurrence in A. Is that true? Is it true the way I did it here? So the answer is no, that's not necessarily true, because the sort of other defining quality of sets is, besides being fast for checking if something is in a set, they're not ordered in any way. They have no notion of ordering, and so in particular, you're not guaranteed that the elements appear in any particular order when you list them, and that's all that converting them to a list is doing. It's just listing the elements of the set and storing those in a list, but they come in any order. And so then the answer is both A and B, but not all of the above, because C is not true. Okay, and here's things maybe you should experiment with. So 2 versions of anonyms, which is this, takes a list of words and returns a set that contains W if W is in the list of words, and the reverse of W is in the list of words. So there's one version of that, which looks like this. And there's a 2 version of that, which first creates a set of words from the original list and does this. So this is one you should probably test and work your way through to decide what's happening and whether it's fast or slow. So first of all, suppose you give it a list with 100 words. Is it fast or slow? In particular, will it only take a second or less than a second to execute, a fraction of a second, or will it take more than a minute for 100 words? So I'll give you a hint. Your computer's clock speed is measured in gigahertz. So does anyone know how much a gigahertz is? Or what that means even? Pardon? Yeah, so gig is the sort of prefix for 10 to the 9 or a billion. And a hertz is a cycle, like an up and down sort of cycle, like a wave, one wave out of many. So your computer's clock speed is measured in billions of cycles per second. And computer instructions typically take 1 or 2 cycles to execute. So computer instructions execute at a rate that's measured in billions of instructions per second. So if I give you something that contains 100 words, do you think it's going to take more than a minute to execute? No. Whatever it's doing, it's not executing billions and billions of instructions. In particular, it's not executing, let's say, more than 60 billion instructions if you only give it a list of 100 words. So both of these things will be fast if you give it a list of 100 words. And next question then is, well, suppose I give it a list of 100,000 words. So a large list. So is one of these, can you point to one of these that might take more than a minute to execute? So let's take a look. Anonyms 1. So words is a list with 100,000 things in it. So words is a list with 100,000 things. Okay. So I'm going to go through that list and look at each word in there. So 100,000, that's not terrible, right? That's this number here. And remember, we're comparing that to computer clock speeds, which are about 1 billion. Okay, so I'm going to go through and I'll say, okay, first time I look in here, W is equal to A. And I want to decide if I want to add W to the collection of things that I'm building here, meaning I want to know if it's an anonym. And how do I know if it's an anonym? Well, I look in this list of words to see if the reverse of W is in the list. So, okay, W is equal to A. I reverse it, and I check, is that in the list? And, yep, there it is. So that was really quick. So good. I add that one in. Next thing is alphabet. So I reverse that. And I want to know, is that thing in my list of words? Okay, so that means I have to look here. Is this thing equal to A? No. Is this thing equal to... is this word equal to this thing? No. 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 So I have to do that 100,000 times. And then at the end of that, I realize, okay, finally I conclude this thing is not an anonym because I didn't find its reverse there. So I just did 100,000 steps to rule out this particular word. And most of these are not anonyms, right? So most of these 100,000 words here are not anonyms. I reverse them and I get some nonsense that's not a word. So for each one that is not an anonym, I have to go through this whole list, checking to see if its reverse is there. And that doesn't end until I get to the end of the list and realize that I looked at everything in the list and it's not there. So that means for 100,000 different words, for each one I need to test if it's an anonym, which means I have to compare it against 100,000 words. So if I just do something simple like count the number of comparisons that I do, it's 100,000 times 100,000. And that is, well, we can just do the multiplication by counting zeros. So that's, I see, 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. 10 billion, and that's going to take a while. And if you don't believe me, run the code or remember that we did this, basically this experiment in class before. And the second one is actually a trick question. Do you think it's going to be fast if I turn this into a set first? You should. It's the right thing to do if we want to check if things are in there. But if you look at how I'm using the set, it's the wrong way. So if you want this to be fast, you should check if the reverse of the current word is in the set of words, not the list of words. Otherwise, you just have to look through the whole list anyway. So these things are delicate, yeah, I mean, you should understand what you're doing and why you're doing these things. So don't just say, "I'll make it into a set and it'll be fast," but understand what sets are good for. They're fast for checking if things are in them, for adding and removing things. Okay. And here's the bonus question, which is a joke question, but I'll let you ponder it. Okay, so go and make up your own questions, come up with your own examples, figure out what's happening with these questions. I'll post this code immediately when I get back to my office, or not this code, this sample midterm. If you want to test the code in it, go ahead. Just remember that it's Python 2 code, so there's some issues that are, some things that won't quite work for you. See you in class.